potential due to an electric dipole. Written. Draw an electric dipole. This is an electric dipole. It carries equal and opposite charges separated by a small distance. Okay. अच्छा, इससे पहले we had found out electric field intensity due to an electric dipole in the previous chapter. ठीक है, तो जब हमने इलेक्ट्रिक फील्ड इंटेंसिटी किया था फर्स्ट चैप्टर में, then we had taken two different points. First was the axial point that we had chosen. This is the axial point, and we had found out the electric field intensity at axial point P, at point P on the axial line of electric dipole. And second point that we had taken was the equatorial line, right? Equatorial line. This we had taken, and we had found out the electrostatic potential, sorry, electric field intensity at some point P on the equatorial line of an electric dipole. This we had done for इलेक्ट्रिक फील्ड इंटेंसिटी, है ना. हमने इलेक्ट्रिक फील्ड इंटेंसिटी एक्सियल लाइन पे फाइंड किया, है ना. हमने इलेक्ट्रिक फील्ड इंटेंसिटी एक्सियल लाइन पे फाइंड किया और हमने इलेक्ट्रिक फील्ड इंटेंसिटी इक्वेटोरियल लाइन पे फाइंड किया. So at these two different positions we had found out the electric field intensity for an electric dipole. But here वहां पे क्या फाइंड किया था, इलेक्ट्रिक फील्ड इंटेंसिटी फाइंड किया था, and we had chosen two different positions, axial line and equatorial line. यहाँ पे we will find the electric potential due to an electric dipole. But here neither we will consider the axial line nor we will consider the equatorial line. Rather we will choose an arbitrary point P, okay, anywhere around the electric dipole. Okay, so instead of taking this axial point and equatorial point, we will choose an arbitrary point. And this point is arbitrary. Arbitrary means we can choose this point anywhere near the dipole. This point P can be here, this point P can be here, here, anywhere you can choose this point. Okay, कहीं पे भी आप इस point को choose कर सकते हो, and we will find electric potential at that point P due to this dipole. ये point P कहीं पे भी हो सकता है. This is an arbitrary point. Clear है? इसमें कोई doubt है? ठीक है, तो ना तो हम इक्वेटोरियल ले रहे हैं ना हम एक्सियल ले रहे हैं. तो ये एक्सियल भी हो सकता है, ये इक्वेटोरियल भी हो सकता है, ये यहाँ भी हो सकता है, यहाँ भी हो सकता है, यहाँ भी, कहीं पे भी ये पॉइंट हम चूज कर रहे हैं. एंड वी विल फाइंड इलेक्ट्रोस्टैटिक पोटेंशियल एट दैट पॉइंट ड्यू टू दिस डाइपोल. ओके, क्लियर आगे हो गया? इतना इतना समझ आ गया? आई एम गोइंग टू क्लियर द स्क्रीन नाउ. लेट्स ड्रॉ द डाइपोल अगेन. दिस इज माइनस क्यू and this is plus q, and the distance between the dipole, the two charges, distance between the two charges is 2. This is how we take, and we consider the center as this point as O. Let's consider this point as O. This is point A and this is point P. Let's choose an arbitrary point P somewhere here. Okay, and now we are going to find electric potential at this point P due to this electric dipole. Let the coordinates of this point be x, y. Okay, so how do we take the distance? We always take the distance from the center of the dipole, है ना? So from the center of the dipole, distance of this point P where we have to find electric potential is vector r, let's say. In the same way, we can write the position vectors for the charges. Okay, for charge minus q, we can take r1, and for charge plus q, we can take r. This is vector r1, and this is vector r2. Any doubt here? Itna clear ho gaya? Let the angle, this angle be theta. And this point lies at the origin. We can assume this point O to be at the origin. Okay. So if this point is the origin, and if we draw a reference frame, and if we draw a reference frame like this, we can draw like this, a reference frame. Okay. We draw a reference frame, then we can easily see, because this point is xy now. So this from origin, this point P, if we just uh, join this line, then you can see that this point, this distance is x, right? From the origin, because abscissa is x, na? Abscissa is x, means horizontal distance is x. From the origin, this point is x distance away. And if we, and similarly, ordinate is y, vertical distance is y. Okay. So horizontal and vertical distance we can write according to the coordinates of this point. Yes. Now you can see we have three different right angle triangles here. We have three different right angle triangles. Let this point be C. So one right angle triangle, right angle triangle. How many right angle triangle do we have here? First right angle triangle is triangle POC. Second right angle triangle is triangle PBC. And third right angle triangle is triangle PAC. So these are the three right angle triangles that we have. This is one thing. Okay, we will try to understand this topic in parts. Okay, only then we can understand it, understand this in a better way. So let's choose triangle POC first. देखना कौन है. Let's choose this triangle first, P, O, and C. So this angle is theta. You can see. Look at this triangle POC. This angle is theta, and this is R. This is X, and this is Y. So we can apply Pythagoras theorem here. Okay. So when we apply Pythagoras theorem, we'll get R square is equal to X square plus Y square. अंदर बुला लो. ठीक है. R square is equal to X square plus Y square. This is what we get. We can also write X and Y in terms of R. Please have a seat. Just have to wait for another 5 or 10 minutes. See, we can also write X and Y in terms of R. Okay. How can we write X and Y in terms of R? In terms of cos theta, sin theta. Sin theta is perpendicular upon hypotenuse. Cos theta is base upon hypotenuse, right? So this X upon R is base upon hypotenuse. It is cos theta. Yes. So what is X? What is X? R cos theta. And we can write X and Y in terms of R, na? Because R we know, X we don't know. Right? So we need to write X and Y in terms of R. And if similarly we can write for Y. Y upon R perpendicular upon hypotenuse. Y upon R is sin theta. So Y is equal to R sin theta. Okay. Any doubt till here? जरा सा भी डाउट है, अगर थोड़ा सा भी लग रहा है तो अभी यही क्लियर कर लो, बिकॉज ये आगे डेरिवेशन में बहुत लंबा जाने वाला है, बहुत कुछ है इसमें. ओके. द्वारिका समझ आ रहा है?
Yes.
हाँ जी. अब हम क्या करेंगे? और नेक्स्ट स्टेप इज सी. हाँ जी बोलो. हॉरिजॉन्टली और वर्टिकली. यस, वर्टिकल डिस्टेंस और हॉरिजॉन्टल डिस्टेंस. ये बोल रहे हो ना कि एक्स वाई कोऑर्डिनेट्स है, तो एक्स वाई कैसे लिया? हाँ हाँ. ओके. And one more thing, when we find electrostatic potential at some point due to a number of charges, then we apply superposition principle there. So electrostatic potential at P. See, we have two different charges, na, minus Q and plus Q. Electrostatic potential at P will be due to this charge minus Q and plus Q. So let the electrostatic potential at P due to charge minus Q be V1 and due to charge plus Q be V2. So we can write this as V1 plus V2. Yes. ठीक है, लिख सकते हैं या नहीं लिख सकते हैं? Okay. And what is V1? Is minus 1 upon 4 pi epsilon naught Q by R1. Because see, this charge is negative. So we'll put a negative sign here. And V2 is KQ by R1, R2. So 1 upon 4 pi epsilon naught Q by R2. Okay. Now we can take this 1 upon 4 pi epsilon naught outside. And in the bracket, we will have, see, Q also we can take outside because Q is also same for both, right? So in the bracket, we will have 1 upon R2 minus 1 upon R. Is this clear? Any doubt? Gaurika?
Yes,
बेटा ये इंपॉर्टेंट टॉपिक है, कुछ डाउट है तो पूछ लो, अभी ये बोर्ड में आया हुआ है. Okay. Now we will write this R2 and R1 in terms of R. How will we write R2 and R1 in terms of R? So for this, we need to consider different triangles that we have. Okay. So this is one triangle and this is another triangle, you can see. So we will consider triangle PBC. PBC. When we consider triangle PBC, you can see this is a small triangle that we have. So this is your R2. This is your R2. And this, see, this side is BC, right? This is BC. How will we write BC? This BC is this, and this is A, right? So we can write BC as X minus A. Can we write like this? So our BC is X minus A, and this PC is Y. Okay. So we can write R2 square as X minus A whole square plus Y square. A minus B whole square is A square plus B square minus 2AB, and then write this plus Y square. This X square plus Y square is, X square plus Y square is, we have written already, R square. So we can write for X square plus Y square, we can write R square plus A square. And now we have this minus 2AX. This minus 2AX. What is X? What is X? X is R cos theta. So we can write minus 2AR cos theta. And here we have plus A square. Okay. This is R2 square. Can we take R square common? What if we take R square common? We'll get minus 1 here and minus 2AR cos theta by R square we will write. है ना? So R cos theta by R square, so we'll get minus 2A cos theta by R, and then we will write A square by R. This is how we can write. In the same way we can write for R1. As we have written for R2, in the same way we can write for R1. Okay? ठीक है, this we had done. So we have to find potential at pxy, और हमने क्या find किया था last class में?
y किया था,
x और y को हमने r cos theta r sin theta लिखा था, और फिर potential at p, और फिर हमने R2 निकाला. So we can find R1 in the same way. So for R1 we will consider triangle PAC. So consider triangle PAC. Okay. So when we consider triangle PAC, so apply Pythagoras theorem here. So this is AP square. So AP square is equal to AC square plus PC square. AP square is R1 square, right?
Yes, ma'am.
And AC square is X plus A whole square. And PC square is Y square. So we get X square plus A square plus 2AX plus Y square. Okay?
Yes,
ये किया था?
ma'am.
Now this X square plus Y square can be written as R square. So this is R square plus A square, and X is equal to R cos theta. This is 2AR cos theta. And we will take this r square common. In the bracket, we will write 1 plus a square by r square plus 2a by r cos theta. Yes, this is my r1 square. Plus a square by r square minus 2a. ये प्लस है, प्लस आएगा 1 प्लस a स्क्वायर प्लस b स्क्वायर होता है, ठीक है। नाउ हाँ जी बोलो,
कोई नहीं, सही है।
नहीं बोलो, डाउट है तो
नहीं,
बोलो।
नहीं, इसलिए वो हो गया।
अच्छा, अब इलेक्ट्रिक पोटेंशियल, वी हैव टू फाइंड इलेक्ट्रिक पोटेंशियल एट P. So electric potential at P is equal to electric potential at P due to charge minus Q plus electric potential at P due to plus Q. Yes, due to plus Q. So this is minus Q. Because of minus Q, we have minus 1 upon 4 pi epsilon naught Q by R1. And because of this plus Q, we can write plus 1 upon 4 pi epsilon naught Q by R. और यहाँ पे Q upon 4 pi epsilon naught लिखें. And in the bracket, you will get 1 upon R2 minus 1 upon R1. Okay. Now we can write this as Q upon 4 pi epsilon naught. 1 upon R2. What is R2? R2 square we have found out, right?
Yes.
So R2 is R square 1 plus A square by R square, बताओ, minus 2A cos theta by R. Yes. Cos theta by R raised to the power. Yes. This is how we'll write. In the same way, we can write for R1. So 1 upon R square. 1 upon R square 1 plus A square by R square plus 2A cos theta by R bracket close, curly bracket close की power half, और फिर आगे आ जाएगा square bracket. ठीक है। Should I clear this side? This one?
Yes.
Okay, so now we can write potential, electric potential at P is equal to, see, if we consider this, this A, if we consider this R very, very greater than A. Okay, if we consider this R very, very greater than A, then your A square by R square can be neglected. है ना? We can neglect this, it can be neglected. So we just don't write this A square by R square in both the terms because we are neglecting this. So now we are left with Q upon 4 pi epsilon naught. And see, we have 1 by R square, and R square raised to the power half is R square raised to the power half. What do we get? R square raised to the power half is R. Yes? R square raised to the power half is R. So we get R 1 upon R, and in the bracket we have 1 minus 2A cos theta by R raised to the power. Okay. Similarly, we can write for the second term. it's minus 1 by r. In the bracket we have 1 plus 2a cos theta by r raised to the power half bracket close. ठीक है? Now we can write this. See, we have this 1 by r and this r belongs to both, right? So we can just move this outside. So we'll get potential at P is equal to Q upon 4 pi epsilon naught r. And here we have, see, 1 minus 2a cos theta by r ki power half. So we can write this as 1 minus 2a cos theta by r raised to the power minus half. And here minus sign, and we can write 1 plus 2a cos theta upon r raised to the power minus half bracket close. So q upon 4 pi epsilon naught r. See, here we can apply binomial expansion, and it says that if we have 1 plus minus x raised to the power n, so we can write this as 1 plus minus nx. Okay, so we'll apply this. So we have this x, in place of x, we have 2a cos theta by r, and this is n minus half, right? This is n. So we can write 1 minus n minus half. Yes, so 2a cos theta divided by minus 2 into half. This is one term, and we have a negative sign. Now we will write 1 minus, or we can write plus 2a cos theta. In the denominator, we will write minus 2, because we are multiplying this by with minus half now. So this is the reason we are writing this minus 2 in the denominator. Minus 2 r and bracket close. What will we get? Q upon 4 pi epsilon naught r. Minus minus plus 2 to cancel, minus minus plus. हाँ जी बताओ. Yes, here we'll have 1 plus a cos theta by r, and in one bracket, then minus sign, 1, 2 to cancel, and now we have 1 minus a cos theta by r in the second bracket, bracket close. What should I write now? Q upon 4 pi epsilon naught r. So we can write 1 plus a cos theta by r minus 1 minus minus plus a cos theta by r bracket close. 1 1 cancel हो जाएंगे. I'm going to erase this now. Answer. Now tell me. Q upon 4 pi epsilon naught r, and here we'll have r in the denominator. In the numerator we have a cos theta plus a cos theta. It's 2a cos theta divided by r. Or we can write this as, see, q into 2a. We have read this q into 2a na, somewhere where we have done in chapter 1. It is dipole moment, right? So q upon 2a is p. So it's p cos theta upon 4 pi epsilon naught r square. Now in place of 1 upon 4 pi epsilon naught, we can write K. So it's Kp cos theta by r square. Okay. Yes.
Yes, ma'am.
Okay, let's take few cases. So let's consider two different situations. Suppose we have axial line. Suppose this point P lies on the axial line. If point P lies on the axial line of electric dipole. See, if we move this point to this angle is theta, right? If we move this point P to somewhere here, then the value of theta will become hmm? बताओ. You are moving this point P here. देखो ये ऐसे है ना, ऐसे है. आप इस पॉइंट को नीचे लेकर आ रहे हो, यहाँ लेकर आ रहे हो, तो थीटा की वैल्यू क्या हो जाएगी? थीटा की वैल्यू डिक्रीज हो जाएगी एंड अल्टीमेटली the value of theta will become 0 डिग्री ना? नहीं पक्का ना? 0 डिग्री हो जाएगा ना? इस पॉइंट P को अगर हम उठा के नीचे लेकर आएंगे तो थीटा की वैल्यू क्या होगी? डिक्रीज 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 एंड अल्टीमेटली विल गेट 0. Theta becomes 0 degree on axial line. So value of B becomes K P cos 0 degree by R square. Cos 0 degree is 1. So Kp by R square. And what if I move this P to the other side then? If we move this P to the other side, it goes there, then it comes here, somewhere here. Then what is the value of theta at this point? 180 degree. So if theta is 180 degree, then B is, बताओ, Kp cos 180 degree, right? And cos 180 degree is -1. Very good, -1. So it's minus Kp by R square. So on axial line, we have either plus or minus value of potential, electric potential. If this point P lies on equatorial line, then what? See, if this point P is here, this is the equatorial point, na? This point perpendicular to the dipole, right? This point is the equatorial point. If this point P lies here, then what is the value of theta? Theta is 90 degree here. So we can find electric potential at this point. Yes? Yes. Electric potential theta is 90 degree. Therefore, electric potential is Kp cos 90 degree by R square. Cos 90 degree is 0, so electric potential is 0 on equatorial line. So when we have a charge and we find electric field intensity at point P, which is at a distance r, then we write electric field intensity as kq by r square, and electric potential at this point is kq by r. So usually we have E inversely proportional to square of r, and here we have V inversely proportional to r. But we have certain situations where E is inversely proportional to r and V is inversely proportional to r square. So one such case is the case of electric dipole. So in case of electric dipole, when we find electric potential at some point P, which is at distance r from the center of the dipole, then electric potential at P is equal to, क्या find किया अभी? Kp cos theta by r square. So we can see in this particular case, our V is inversely proportional to r square. And for a line charge density, for a line charge distribution, and if we find the electric field intensity due to a line charge, and we draw a Gaussian surface of length L, then we first find flux. Flux is Q upon epsilon naught. Q is lambda L upon epsilon naught. Also, we can write flux as E into ds, area. It is 2 pi RL, curved surface. So on comparing these two, you get E into 2 pi RL is equal to lambda L upon epsilon naught. So from here, we get E as lambda upon 2 pi epsilon naught R. So in this case, we have E inversely proportional to R. Okay. तो इसको कंपेयर करो इससे और ये देखो, समझ आ रहा है what I'm trying to explain here? R is the radius of cylinder. Any doubt anywhere?